Things that can be depicted on flat surfaces, such as the screen you are using to view this video, are plane figures. Plane figures have two dimensions, often called length and width. A simple closed curve is a plane figure that does not cross itself and ends at the same point where it begins. And here are some examples. Simple closed curves made up entirely of line segments are called polygons. And here are some examples of polygons. The circled polygon is a concave polygon. The rest of the polygons are convex polygons. We will concern ourselves with convex polygons most of the time. There will be a few exceptions. One of the ways to differentiate between concave and convex polygons is the two-point test. Choose a pair of points in the middle of one of the polygons, such as the two we chose in our pentagon, and connect them. If the line segment is entirely in the interior of the pentagon, and it will be for any 2 points chosen, it's a convex polygon. But in our concave polygon, we can choose 2 points, connect them, and our line segment has to go outside of our polygon and come back in again to get to the other end. While some of the pairs of points we could choose in a concave polygon would include a line segment, which is totally inside the polygon, if there's even one line segment that has to pass outside of the polygon, it's a concave polygon. Polygons with 4 sides are called quadrilaterals. And here are some examples. This quadrilateral is a rectangle. It has 4 right angles. A characteristic of a rectangle is that opposite sides are the same length and parallel. So we'll get out our trusty rulers and we'll measure. And if you can see, one of the measurements is 6 centimeters and the other is 5. So we say that it's 6 centimeters long and 5 centimeters wide. Length and width are interchangeable, but I tend to make length the longer of the two numbers and width the smaller of the two numbers. So we label our rectangle, and because of the characteristics, we know that the opposite sides are equal and parallel, so we can also label the other 2 sides. So we have 2 sides of 6 centimeters and 2 sides of 5 centimeters. The distance around the outside of the rectangle is the perimeter. For this rectangle, the perimeter is 6, followed by 5, followed by another 6, followed by another 5, and we're back to where we started. We add all those up, and we get 22 centimeters. The distance around the outside of the rectangle, known as the perimeter. This lesson is primarily about the space inside the rectangle, which is now shaded orange. It's called the area of the rectangle. And we can put our rulers back and use the rulers to draw horizontal lines at all of the centimeter marks. And then we can also use the bottom ruler to draw vertical lines 1 centimeter apart. We need 4 vertical lines. And then, of course, the whole rectangle is divided into squares. And you can count them, 30 squares, and each square has sides that are 1 centimeter long. So we call each square a square centimeter. So the area of this rectangle is 30 square centimeters, and the abbreviation is the abbreviation for centimeter, cm, followed by the exponent 2, and it's read square centimeters. Often when we are reading fast, we'll say 30 centimeters squared because we see the cm before the little 2, the exponent, and we'll get by if someone says 30 centimeters squared, but it's correctly read 30 square centimeters. Well, there's a formula that can be used for a rectangle. You may already know it, length times width. So we say LW, well, where L stands for the length and W stands for the width. Area is measured in square units. Square units result whenever 2 units of length are multiplied. The 2 units of length should both be measured using the same unit. So if we used inches, it would be 6 inches by 5 inches or 30 square inches. 6 feet by 5 feet, 30 square feet. 6 meters by 5 meters, 30 square meters. And 6 kilometers by 5 kilometers would be 30 square kilometers. Most of our units of area come from multiplying units of length to get square units. But there are 2 units that we don't need to say square first. An acre is already a unit of area, and that's in our traditional system. And in the metric system, a hectare is a unit of area, and both units are used to primarily measure land area. So for most of our work, we'll be starting with units of length, multiplying them together to get square units of length. So this quadrilateral is a square. It's also a rectangle, but what makes it special is that all 4 sides are the same. So instead of marking 2 of them as L for length and the other 2 as W for width, all 4 can be marked with the letter S, and that stands for the length of a side. So the formula used to find the area of a square is S squared. So instead of L times W, it's S times S, which can be shortened to S squared, as shown. And that brings us to some special numbers. Here's a 1 by 1 square. Here's a 2 by 2 square, which then contains 4 smaller squares. A 3 by 3 square contains 9 smaller squares. Then 4 by 4 to get 16, and 5 by 5 to get 25. And as you probably can guess, we can go on infinitely, but we don't have enough space for that. So we'll just say that the numbers 1, 4, 9, 16, 25, and so on are square numbers. They are also known as perfect squares. But sometimes we have rectangles that don't have whole numbers, and we could try to divide this into little boxes, but you might guess some of the boxes wouldn't be a full centimeter on each side. So we'll just use our formula, length times width. So in this case, it's 2.6 centimeters times 7.4 centimeters. We get out our calculator, and our area is 2.6 square centimeters. We can also work a problem like this where there isn't even a picture. It simply states, find the area of a rectangle with length 4.5 inches and width of 2.25 inches. We don't even need a picture. We just get our formula out. We multiply the length times the width, which in this case is 4.5 inches by 2.25 inches. We get out our calculator. We do the work. 10.125 square inches, or if you like fractions, that's 10 1/8 square inches. Now we're going to find the area of a square with side 8.5 inches. We get out our formula for the area of a square, S squared. So that's 8.5 inches times itself. And we get out our calculator, 72.25 square inches is the area of the square. Here's a concave polygon that has 6 sides, so it's a hexagon. But we don't have a formula for a hexagon, so we're going to divide it up into 2 rectangles. And you can see that one of the rectangles is 9 by 6, and the other rectangle is 5 by 4. Well, 9 times 6 is 54, and 5 times 4 is 20. So we add 54 square centimeters plus 20 square centimeters, and the grand total is 74 square centimeters. Well, that's probably the quickest way to do this problem, but we're going to do it another way. We're going to divide it up this way. Well, now we're missing a length of the top segment, but because these are all right angles, we can add the 6 centimeters and the 5 centimeters at the bottom, and that means that the top segment must be 11 centimeters long. And then we need one more length for our bottom rectangle, and we get that by doing 9 centimeters minus 4 centimeters to get the orange 5 centimeters. So that rectangle is 6 by 5. Our top rectangle is 11 by 4, and that gives us 44 square centimeters and 30 square centimeters, and we add them up. And the good news is we get the same answer we got the first time, 74 square centimeters. And then we're going to do it one more way. We're going to outline the whole thing. So now we have one large rectangle, which is a 9 by 11. And then we're going to subtract out the smaller rectangle that we've marked out at the lower right, and that's a 5 by 5. Turns out that's a square. So 9 by 11 is 99. 5 by 5 is 25. 99 square centimeters minus 25 square centimeters is, you guessed it, 74 square centimeters. We've done the same problem 3 ways, and the good news is we've gotten the same answer each way. The space inside a plane figure is called area. Area is measured in square units. The formula for the area of a square is that the area is equal to s squared, where s is the length of the side of the square. The formula for the area of a rectangle is area is equal to L times W, where L is the length and W is the width of the rectangle.